After a 6-month effort, a device on the Mars rover aiding in the search for signs of ancient microbial life is back online. NASA's Perseverance rover's SHERLOC scanning habitable environments with Raman Luminescence for organics and chemicals instrument analyzed a rock target with its spectrometer and camera for the first time since encountering a problem last January. The instrument plays a crucial role in the mission's search for traces of ancient microbial life on Mars. Engineers at NASA's Jet Propulsion Laboratory in Southern California confirmed on June 17 that the instrument successfully collected data. Kevin Hand, SHERLOC's principal investigator at JPL, said the 6-month effort involving diagnosis, testing, imaging, data analysis, troubleshooting, and retesting couldn't have resulted in a better outcome. Mounted on the rover's robotic arm, SHERLOC uses two cameras and a laser spectrometer to investigate organic compounds and minerals in rocks altered by watery environments, potentially revealing signs of past microbial life. On January 6, the device's moving lens cover, designed to protect its spectrometer and one of its cameras from dust, got stuck in a position that prevented SHERLOC from collecting data. An analysis by the SHERLOC team indicated a fault in the small motor responsible for moving the protective lens cover, as well as for adjusting the focus for the spectrometer and the autofocus and context imager OCHI camera. The team initiated a long and meticulous evaluation process, testing potential solutions on a replica SHERLOC instrument at JPL to see if and how the lens cover could be moved to the open position. Black holes are fascinating because they involve the simplest things in the universe. Their only properties are mass, electric charge, and angular momentum spin. Yet, their simplicity leads to the fantastic feature of an event horizon at a critical distance from the black hole, a physical, though in the simplest case, spherical surface. Anything closer to the black hole, within the event horizon, can never escape. Black holes were predicted in 1916 by Karl Schwarzschild, a German soldier suffering from the painful autoimmune skin disease pemphigus while serving on the Russian front. Using Einstein's general relativity equations, he assumed a massive, non-rotating, perfectly round object in an otherwise empty and unchanging universe and discovered the event horizon. The radius of the event horizon is proportional to the black hole's mass. Inside the horizon, not even light, the fastest thing in the universe, can escape the hole. The team, among other steps, tried heating the small motor for the lens cover, commanding the rover's robotic arm to rotate SHERLOC in different directions using Mastcam-Z images for support, shaking the mechanism back and forth to dislodge any debris possibly jamming the lens, and even using the rover's percussive drill to try to free it. On March 3, images from Perseverance showed the ACI cover opened more than 180 degrees, clearing the image's field of view and allowing the ACI to be placed near its target. With the cover removed, a line of sight was established for the spectrometer and camera. Kyle Luckett, SHERLOC's deputy principal investigator at JPL, said, "We were halfway there. We still needed a way to focus the instrument on a target. Without focusing, SHERLOC images would be blurry, and the spectral signal would be weak." Like any good optometrist, the team set out to find SHERLOC's prescription. Unable to adjust the focus of the instrument's optics, they relied on the rover's robotic arm to make small adjustments in the distance between SHERLOC and its target to achieve the best image resolution. The team instructed SHERLOC to take photos of a calibration target to check the effectiveness of this approach. "The rover's robotic arm is fantastic," Luckett said. "It can be commanded in quarter-millimeter steps to help us evaluate SHERLOC's new focus position and place SHERLOC with high precision on a target. After testing first on Earth and then on Mars, we found that the best distance for the robotic arm to position SHERLOC is about 40 millimeters, or 1.58 inches. At this distance, the data we collected should be as good as ever."